Hello everybody, I'm Alexy Khrabrov, the organizer of SF Spark and Friends, and here we are on location at Quantcast, hosting a talk on Kudu. Kudu is a new system out of Cloudera. We have one of the core members of the team with us here, Jean-Daniel Cryans. We just heard about Kudu announced. I think we are happy to host one of the first talks.
Yeah, that would be my first talk in public, actually.
That's fantastic, right? So we are super fortunate to hear about it, and we'll ask JD a little bit about the ecosystem, about his interest, and why Kudu is the next thing we should try. So welcome.
Thank you.
So let's start a little bit with the history, right? So I know you are HBase PMC, and you were at StumbleUpon, where HBase kind of one of the places where HBase grew. And so can you tell us a little bit how this happened, why StumbleUpon needed something like HBase, and kind of what are the crucial lessons you learned working on HBase there?
That's a lot of questions. So if we start with, from the beginning, StumbleUpon was funded by 4 Canadians, one of them Garrett Kemp, who is now the chairman of Uber. Mm-hmm. So back then with StumbleUpon, what he saw is that they have a business model that can scale infinitely. Mm-hmm. Like as long as they can get more traffic, they can make more money. So they're like, well, we have this infrastructure with MySQL, it scales. I mean, you can make it scale, but like, is there something better out there that we can like put the whole application on it and continue scaling up? Mm-hmm. He identified a bunch of things, but then he hired Ryan Rawson, who was then at Google, I believe. Mm-hmm. And he tasked Ryan back then to find what would that database be. He eventually picked HBase, and then he built a team around that. So I was the second hire to work on HBase there.
Yes. So how did this happen, right? Basically, you have a standard kind of data requirement for web scale storage, and everybody did sharded MySQL, and it was good enough for Facebook. How did you guys decide to implement HBase? And it obviously was a lot of work to do this. And how did you manage to do this kind of while maintaining StumbleUpon going?
Yeah, that's an interesting story, because when we started using HBase at StumbleUpon, so they started using it just before I came on, exactly 6 years ago in 2009. Mm-hmm. And back then, HDFS didn't have data durability guarantees. Like, so if you lose a machine, you actually lose data. Mm-hmm. So it was, in the beginning, a very wild ride. So they just first identified the things that they needed to scale the most, like that just didn't fit in MySQL anymore. Mm-hmm. And then like the rest was just like an offload of more and more stuff from MySQL. And what remained eventually in MySQL was just what really made sense in the relational world. Mm-hmm. All the other stuff, like all the comments, they were served straight out of HBase. All the counters, the badges, that was all done in HBase. Mm-hmm.
Interesting.
So they took a big risk. Yes. Garrett Kemp, actually, he believed strongly in HBase, even though like back then, as I said, didn't have durability. Maturity was like, it was a pretty young project. But you read the big table paper and you think, man, maybe I can have my own little like Google infrastructure internally, right? Mm-hmm.
Well, so I just realized when you mentioned the Canadian origins that HBase is a Canadian thing.
No, it's not.
Yeah, I understand. But I mean, it's kind of funny. Like it all came into focus. It's interesting.
But it was Michael Stack and Jim Kellerman at PowerSet. Like, well, actually, they took it over from what's his face from Washington. I don't remember. But it's really Stack and Jim who back then picked up the project at PowerSet, because Chad Walters, if I remember correctly, like they had pretty much the same issue and they had the same goals. Mm-hmm. But eventually PowerSet was bought by Microsoft. Yes. And then Stack also came on board at StumbleUpon, and then we had our own little HBase committer team at StumbleUpon. And what we liked about it is we could basically like play with the rest of the community as neutral individuals. Instead of we're vendors, like we're not making money directly from selling HBase, right?
Right. No, I think this is fascinating, right? And so the way kind of it was adopted, and I mean clearly it serves the key need, right? It's like it serves the need of a data store, and we see this theme recurring, and it's unavoidable. People build different engines. They have stream engines and Spark, right? But still you need to store. So it's very interesting for me that you now work on Kudu. So maybe you can tell us. I mean, you will have a technical talk, but kind of obviously HBase was not enough, right? Because if HBase will solve all the problems, you will just do HBase, right? So I mean, this is basically what I'm coming in with. That's my assumption, right? And I think it's very interesting that you of all people work on Kudu, right? So maybe you can explain basically how this happened and why we need Kudu as kind of next thing. Is it a successor to HBase? Is it a complementary thing? Where Kudu is on this spectrum of databases?
Right. Well, so like Stonebreaker said, one size doesn't fit all. So HBase, very solid database, but won't solve all your problems all at the same time.
Yes.
And on a more personal level, I had been working on HBase for 4 or 5 years when I started working on Kudu, and I was ready just for another challenge because HBase was like the first thing I did out of university.
Okay.
So I just welcomed the challenge. Also a different language, C++. And
Okay.
so what Kudu tries to do, it tries to be the one system that can replace your Lambda architecture. So people will build systems where they're going to have, let's say, a stream of inserts, also updates and deletes that go into maybe Parquet files. Then they put Impala on top or some other query engine, Hive, and then they run their analytics. And the problem is, well, HDFS is write once, read many kind of system. So if you want to do updates, and you don't have a system like HBase, then you gotta handle your own compaction of the files and making sure that the data it is then uploaded into whatever query engine that you're using. So on the other side, you can use HBase for that, but then HBase on the scan side, like long sequential reads, it's very slow because that's not really what it was built for. So Kudu, what it offers is like being, on one hand, doing really fast sequential reads while being an updatable store. So instead of having maybe a mix of HBase and Impala or your whole system around the managing of the Parquet files, you just have one system, it's Kudu. It's almost as fast when you do sequential scans, when you do scans, almost as fast as Parquet, and almost as fast for random reads on the other side as HBase.
Interesting. So
we're not claiming to be the best.
Right.
We're claiming that it's going to be enough for your needs.
So if you can do very fast sequential scans, it means it's a good solution for streaming data. So if you have something like Kafka, right, and you have a lot of stuff. So normally people debug the streaming systems by having their data in Kafka and then rewinding and replaying everything. Right? Like this is typical Spark streaming setup, right? So you have Kafka going to Spark. So it sounds like I should be able to use Kudu for the same thing. Like, can it be like a permanent storage for streaming data? Can I just kind of store it all there and endlessly, and then I can replay some of this when I'm debugging, and then is it kind of a feasible model?
I mean, yeah, we definitely want Kudu to be your one data store in those kinds of use cases. Because what we're trying to simplify is like having all those different storage engines that you have to use in order to accomplish whatever goal that you have. But like, so in the demo that I'm gonna do today, it's Ted Malaska, he wrote it, and you have like basically online games are being played, and there's winners, and then there's points. All that data is being streamed, like directly sent to Kafka. So then Kafka can, like, it's a permanent queue, so you can buffer up like if there's some kind of pushback, and then it uses Spark streaming to pull from Kudu on one side and pull from Kafka on the other side and do all the aggregations and then push it back to Kudu.
Interesting.
So that's really one use case that Kudu is perfect for.
Interesting.
So it's streaming, like not a whole lot of insight, but streaming all the new players, all the new data points coming in, updating your data on the fly. And on the other side, you can use, you could use Spark SQL. In my case, I'm going to use Impala to directly query the data live in Kudu. So you'll see the changes coming in. There's no delay of 1 hour before you can see the new updates. Like you get the new updates as soon as they land.
Interesting, super interesting. And that actually, so when you mentioned that Kudu is meant to replace your Lambda architecture, that was very interesting to me because we have this conference called Big Data Scala, and in order to kind of emphasize why we need end-to-end reactive systems, we did this site called noetl.org, kind of parodying NoSQL, right? And so the notion which Scala community has, we have these reactive systems. You can have Akka as your API, you can have Kafka in the middle as a message bus, then you can have Spark, right? And so you're never dumping data back into HDFS as text, for instance. Like so there is this typical ETL workflow where you grab stuff from one thing, you transform it, and then you dump it, usually into HDFS as text, and then you read it back and parse it, and then something else does something else to it, right? So there is this piece of it. I mean, in ETL is inherently step-oriented. Basically, first you extract, transform, and then you load. So we kind of want to emphasize the fact that you don't need to load it anymore. You should just keep it there. Right. So I wonder, from the Kudu standpoint and the architecture you propose, would you agree that this kind of ETL, old-fashioned ETL with HDFS text storage is obsolete, and kind of you're replacing, so you have now you're supporting kind of streaming, continual processing solution. Can you talk a little bit how you envision Kudu as a part of these architectures?
Yeah. I think for the live data, Kudu will be able to replace a lot of the current architectures, but it's not the one-size-fits-all. So if you have like really cold data, that's gonna go stay in HDFS in your Pocket files. If you're never going to update it, there is no reason to pay the price of all the managing that Kudu is gonna do extra on top, right? And if you're trying to serve a website, then again, that's for HBase. So what lands in the middle is exactly what Kudu is for.
So what about preserving schemas, right? So one of the things we want to avoid with old-fashioned ETL, we don't want to extract anymore. We want to receive an object through an API. We want to assign it to a type. We're fortunately kind of in a strongly typed language usually, hopefully, right? And so we validated it, right? We want to preserve that and hopefully add some consistency checking, and we want to pass the object basically through the whole system, and ideally we want to store it in that way, right? Is it possible, is Kudu kind of built with this assumption that you will have typed objects, you will have schemas like Kafka, right? Yeah. Kafka has a schema server. How does Kudu work there?
So Kudu, unlike Cassandra or HBase, is strongly typed. When you use a normal relational database, you have multiple columns, they each have a type. Kudu is exactly the same way, there's nothing new there. And the same thing with your keys. Instead of having a special column that's your key, you pick the columns that you want as your keys, be it composite, maybe there's only one, and again, that's something that people are very familiar with. We don't have nested data types yet, but that's also something that's going to be on the roadmap.
Interesting. How big are the objects? Do you have some optimal object size? Would you handle large objects? We have a lot of PDFs in my use case. Can you send binary blobs, several?
You can, but that's not really the kind of use case we're targeting in the beginning. If you have an analytics use case, you're rarely doing analytics on PDFs. Maybe you are, but I don't know about your use case.
No, we can extract a lot of text from it, but there will be a bunch of metadata which is not as big, but but there is a binary blob associated with.
Right. You could. It really depends on the size, and if you're talking about megabytes here, I would say that Kudu, it's going to have a hard time since there's no optimization whatsoever done for large, medium or big objects. But there's a lot of stuff in the back end. There's always this problem, in other systems, of write amplification, where you're always doing background compactions, and if you want to update them, you have to, like in HBase, if you do a major compaction, you have to rewrite the whole data set. So there's a lot of smarts inside Kudu where it's only the data that's the most fast changing that we're gonna recompact. If you have large blobs that you don't really change often because that's your text. You might be computing things about that text that's gonna change, but not the text itself. We're never going to try to rewrite the text if you have updates on the other columns, because Kudu is a columnar store, a true columnar store, unlike HBase or Cassandra, which are more column family oriented. So we really store each column separately and do the appropriate encodings.
Interesting. So let's say I have a lot of documents, and then in my use case I will constantly improve my machine learning and extract more metadata and more. I will do different extraction, right? So for each ID, document ID, I will have a better and improved version of various kinds of metadata. This is kind of a useful, good store for this kind of stuff where I want to have basically I want to replace, a lot of stuff in certain columns.
I'd say it depends. If the one thing you're doing the most is updates and deletes, I would say use another kind of data store like HBase or Cassandra that are where writing is free. You don't need to write when you don't need to read when you write. You just write. Update is a write. Delete is a write. Whereas in Kudu we have the string enforcement of the row key. So if you want to write something or update something, we first have to check if it exists.
Yes.
And then there's a lot of optimizations we do on the scan side. Like if you want those fast scans, there's something you got to trade off, right? So if you have a lot of updates, we use what they call delta redos and delta undos. So from your base data, we have to apply all the updates that you've done in order to get you your final data.
Oh, okay.
So if you only have a few, that's fine. If you have a whole lot and that's your main use case, then Kudu will not be as performant as you want it to be.
So I would say, you know, we can so a little bit in the middle, right? So let's say we extract a bunch of text, and that probably will stay the same. So we will improve our algorithms iteratively, right? And so a typical use case will have a whole collection of stuff, and the metadata will mostly stay the same. So, but we might improve our name extraction. So, you know, maybe 10%, maybe 5% of text will change. So, can I give you kind of, can I, like, let's say I maintain my metadata in a kind of in a JSON file, right? And I know on my side, like I know how to diff my metadata, right? So you know, can you take my diff function and would it make your life easier if I would tell you, I know how to update this column with this field because it's kind of my metadata which is structured, and I only kind of, you know, I have a list of, you know, people names in this document. So like inside of JSON there is an array, and in that array I added 3 more names and replaced one. Like so that, like I know specifically which records changed. Would knowing how my fields differ, like having a diff function for me which is most efficient, simplify your life?
Not really. Right now, if you try to update a field, like you have to provide the whole field that you want to update. So, but as I was saying earlier, we want to add those nested data types. So you have one field which is actually composed of many fields, and you only want to update one thing in there.
Exactly.
That's the kind of optimization that nested data types usually handle, and that's not something that we have. That's something we want to have.
Cool.
Kudu is only.
Compile it a little bit and see how, you know.
Kudu is still only in beta, and we released it 3 weeks ago. So we still. But the thing is, the reason it was closed sourced at Cloudera for a long time, like almost 3 years, right? And now we're releasing, but we're not releasing a final product. We're releasing as a public beta, and that's because we're in a mode where we want people to tell us about their use cases and see, like, we don't want to prioritize like things too soon.
Yes.
Like just by ourselves, we want to, based on feedback, what should we be building for this data store? Cool.
So it's good, you know, to become like, you know, if like somebody wants to work well for the use case, you know, they should become a pilot customer and they should try it and they should contribute feedback.
Right, well, also it's an open source database, so if you want to contribute the nested data type implementation, patches are welcome, as we say.
Yeah, well, I did a lot of C++ in the early 2000s, and I vividly remember writing Corpus servers in C++. And yes, and we actually proposed to add a flag to G++ called -- not an idiot, which will remove certain warnings from auto-generated Corba. So so here's a question for you. I mean, this is pretty big difference, right? So you worked in Java, and as I understand for HBase, you almost had to kind of write Java, which is almost like assembly, like Java, which is almost like C, right? Like we had to do low-level Java, and so kind of is writing the database in C++ liberating? Like, do you really kind of like you don't need to pretend it's C? You can actually write it in C. Is it you know? And I think the same thing goes for Impala. Like, is this like what is your take on this choice? Java on the one hand and the whole ecosystem versus C++ for the database?
Yeah, we always get this question. And again, there's like two sides for it. Like there's the personal side where for me, I had been working in Java for basically my whole professional career and like hardcore Java, right? Like where you're handling terabytes of data.
Yes.
And now making this switch to C++. So again, on the personal side, this was like a new challenge for me. I wanted to learn something new. I wanted to do something that I've been doing, but in a different language. It helps you like understand other things better. I'd say like it gives you another perspective.
Can you elaborate? Like, what is the perspective?
I'd say the first perspective is like the garbage collector in Java. Man, this is the one thing that really kills.
It's useful?
It's useful, but in big systems where you have a lot of data going through the JVM, it's mostly a hassle. So you're always trying to put stuff outside of the heap. Like in HBase, like the first thing we got outside of the heap was Well, it's not really outside of the heap. Like we use direct byte buffers for them, or just byte buffers for the mem store. So now you're managing your big blob of bytes. And then the next thing was like for the block cache, because you want to, like for machines today, 256 gigs of RAM it's a lot, but it's not like crazy.
Right.
And years ago it was 64, but like try creating a JVM that spans those like 250 something gigabytes.
Yes.
And then you hit a GC, it's a full GC, it's like end of the world, that node is gone, right?
Yes, yes.
So you want a block cache that fits in RAM, but not on the JVM, that again, you're going off the heap. So all the effort, like in C++, as long as you're managing your own memory, and there's a lot of tools now that exist to make sure you don't have memory leak, that you're always destroying the object you're supposed to be destroying. Like our build environment has, like we have memory checker, we have address checker, we have thread checker, and we limit ourselves to a set of libraries that are like well known in C++, that we're not actively trying to show ourselves in our foot.
Okay. So, but JVM is kind of almost inextricably linked with the big data ecosystem, right? Because we assume big data is Hadoop and it's JVM, and you basically assume you have a distributed system in JVM and everything which it entails. How do you find a system written in C++ interacting with this? Like, do you care? Is it a disadvantage that it's you don't have everything which Java gives you for free already? How did you find it in practice?
It's a trade-off, I would say. It's definitely a trade-off. Like I wouldn't say like, oh my God, C++, best solution. Why isn't everybody going C++? There's a lot of people, well, like me, like 3 years ago, that wouldn't touch C++ projects. So that right there's a bunch of contributors that you can't really get. On the other side, there's a lot of people that are like, oh my God, finally something in C++ on the storage side, man. And then we have Impala, which is already in C++.
Yes.
And other projects are also looking, like Spark, the Tungsten project, isn't it like also going away from Scala and the JVM?
I think it's memory management. Kind of. I mean, I think people want to manage memory kind of in artisanal fashion, right? but I think a lot of them are trying to stay within JVM. I think Flink did this, right? So I think the question, like what you've done with HBase, right? So if you can do a reasonable job from within Java. But yeah, that's interesting.
And there's a lot of things that we do in Kudu that you wouldn't be able to do in the JVM, like using the SSE instructions or the SIMD instructions. You have to go through the JNI interface in order to be able to get there, right? So this is something that we can just naturally do in C++.
Okay, no, this is interesting. So I haven't realized that Kudu was in gestation for 3 years.
Yeah.
Right? It's maybe like the best kept secret because I haven't heard about it. So
well, you can go on. There's a question on Quora. I think it was asked 2 years ago, and it was, what is Stadlibcon doing these days? Because Stadlibcon is the tech lead for Kudu. It's basically his brainchild. Like he thought about this 3 years ago. He was the one working on it mostly, and he's the one that knows like everything about Kudu.
So how come we never heard about it? Was it like a skunkworks project? Was it kind of slowly brewing, or?
Yeah, like we're still a very small team, like six people. So we were just the first thing that was built was just a really fast columnar data store, and then on top of it we built the rest. But we wanted to be able to iterate really fast internally before going outside, and then like going for contributions, which is like a model that Drill took. Like they went from like let's design by committee and then build that way, which is also like another very valid way of doing things. That's the way we chose.
Okay. So I'll kind of wrap up with a very philosophical question, and even kind of very abstract. So I had this very interesting conversation with Evan Weaver, who has a company called FaunaDB, which is a different take on a database, and kind of it's hasn't launched properly yet. So I don't know much about it, but we just had this general discussion with Evan about the role of the database, and so he built data stores at Twitter and handled dramatic throughput. So he has kind of first-hand experience with the systems, and obviously Twitter is using messes, and kind of they have their own streaming, so they need to build the whole big data stack because they have a user. So he actually mentioned some interesting ideas, and he basically said he's thinking of using like query level processes as granularity level, right? So and kind of, if you think of this whole Lambda architecture, the whole stack, so you're assuming that you have distributed systems such as Akka, Kafka, Spark, Cassandra, and they're kind of, they have these big nodes. They're assuming they have a machine to put a daemon on and do something there. But in the end, the only thing they're doing, they're running queries. So why not focus on queries and basically have this whole cluster instead of kind of putting together all the things and putting them in Docker containers and using messes to balance them and schedule them. Why don't we drop down to the level of the final work result, which is a query, and think of it as a process, right? And then basically when we schedule these queries on the cluster, we know exactly what we're working with instead of having to move like little Linux light containers around, right? So it really struck me as a revelation, right? That if in the end, if all we want to do is run queries against some stream of data, why don't we optimize the whole thing for this purpose? So I'm just wondering what's your take on this, having built Kudu for the streaming case, right? I mean, this is like very new to me. I'm trying to understand, the meaning of this. So I'm just kind of relating it back to you, and kind of I'm wondering what's your take on that?
I would say I'm exactly where you are. Actually, that's the first time I hear about this idea. I definitely need to spend more time thinking about it. But I wonder what the trade-offs are, because there's nothing perfect, right? So if you're doing this, what are you not able to do? That would be my first question. Right.
So, but in that sense, Kudu is kind of it's another distributed system, right? So you want to coexist effectively. Like if you run Kafka, Spark, and Kudu, you will have the daemons in each node, right? So like in your current situation, like we'll hope like the locality will be achieved by somehow making everybody play together, right? So. Yes, I mean, just something I kind of, fascinating.
Well, I mean, designed by composition, I think everyone working on their own piece, that's basically what the Linux model is, right? And I think it's a good model.
All right. Well, thank you very much for sharing, and we're looking forward to your talk.
Thank you very much.